All right, this is a lesson from Wednesday, and we're solving trig functions by factoring. So I'm on worksheet 6A. I'm looking at number 5. So on number 5, we've got a quadratic with two terms. And anytime you have a quadratic with two terms, usually, but not always, usually there's a GCF that can be pulled out. And if you look at number 5, they both have a cosine. So what we're going to do is we're going to pull one cosine out. So we're going to go rewrite this as cosine theta parentheses 2 cosine theta plus 1. Now when you're factoring, you're going to take each factor, and I have 2 of them, and make them equal 0. So I'm going to have cosine theta, that's my first factor, equal 0. And I'm going to have 2 cosine theta plus 1 equals 0. And now I have a problem just like we did on the first 2 videos where I just go look at my unit circle. So on the first one, cosine theta equals 0. Well, cosine theta equals 0 at pi over 2 and at 3 pi over 2. On the second side, I have to subtract 1 first and then divide by 2. So we have cosine theta equals negative 1 over 2. Cosine is negative 1 over 2 in quadrant 2 and 3. So theta is going to equal 2 pi over 3 and 4 pi over 3. Okay, now let's go look at number 8 on the worksheet. Number 8. On number 8, we also have a quadratic, but this time I have 1, 2, 3 terms. When you have 3 terms, what we're going to try to do is solve by factoring. So we're going to use a method called guess and check. So what is the only way I can get a 2 out front by multiplying? Well, the only way to get a 2 is to do 2 times 1. So I'm going to have 2 cosine theta and 1 cosine theta, because 2 times 1 is 2. My last number is a negative 1. And the only 2 numbers I can multiply together to get a negative 1 are positive 1 and negative 1. So this next step is called the guess and check part. I know that I'm going to put a positive 1 either first or second, and I'm going to put the negative 1 either first or second. So I have to guess and see which one is correct. I am going to guess the positive 1 is going to go here, and the negative 1 is going to go first. Then this is how you check. That was my guess. So my check is 2 cosine times 1 cosine is 2 cosine squared, so that part's right. 2 cosine times 1 is a positive 2. Negative 1 times cosine is a negative 1. 2 cosine minus 1 cosine gives me my positive cosine. So I know I did it right. Now I'm going to do just like we did on problem number 5. I'm going to go teach each one of these factors and make them equal 0. If I solve the first one, I'm going to add 1 to both sides, divide by 2, I get positive 1/2. If I solve the second one, I'm going to subtract 1 from both sides, and I get negative 1. So you're looking for where on the circle does cosine equal a positive 1/2. That's going to be in quadrant 1 at pi over 3, and in quadrant 4 at 5 pi over 3. Where on the circle does cosine equal negative 1? Well, cosine equals negative 1 only at pi. Okay, now we're going to go take a peek at number 9. On number 9, I have tangent theta minus 1 times secant theta minus 1. They're already factored, so these are actually pretty easy. I'm just going to go make each one of these factors equal 0, so it turns into a problem just like what we did on Monday and Tuesday. I add 1 to both sides, I get tangent theta equals 1. I add 1 to both sides, I get secant theta equals 1. Tangent is positive 1 at pi over 4 and at 5 pi over 4. And secant is really the reciprocal to cosine, And since I wrote the reciprocal word, I have to take the reciprocal here, and the reciprocal of positive 1 is still positive 1. And cosine is equal to positive 1 at 0. So I have 3 answers. All right, the last one that I am going to set up with you is number 13. I'm not going to finish it all the way, I'm just going to set it up. So 13 is special because it's got a sine squared and it's got a cosine. So what we're going to do is we're going to use one of our identities from the top of the worksheet. In fact, the identity that we're going to use is an identity that has a sine squared in it. So my identities with sine squared are my double angle formula, and then my Pythagorean identity that in my class we called Phineas and Ferb. So I'm actually going to use the Phineas and Ferb because if I solve this for sine squared, all I'm left with is 1 minus cosine squared. So I'm going to come back to problem number 13. And right here where I see sine squared, I'm going to replace it with 1 minus cosine squared. And now, as I work this problem, I only have cosine left. So I'm going to distribute my 6. Making sure to distribute through both terms. I'm going to make the left side equal 0 so that my squared can be positive. If I make the left side equal 0, I have positive cosine squared plus 6 cosine theta. If I move this 1 over, I'm going to subtract, and then I have a plus 5. From there, it's a lot like problem number 8. We're going to go factor. I'm trying to figure out what can I multiply times itself to get cosine squared. Well, that's easy. Cosine and cosine. Then I have to figure out what can I multiply to get 5 that will still add up to 6. Well, 5 times 1 is 5, and 5 plus 1 is 6. So these are my two factors. So just like we did on problem number 8, we go set them both equal to 0. So I'm going to come still some room over here on 15. So I'm going to go write cosine theta plus 5 equals 0, and cosine theta plus 1 equals 0. So the first one gives me cosine theta equals negative 5, and the second one gives me cosine theta equals negative 1. Well, cosine theta on our unit circle will never be negative 5, so that one's not going to give me a solution. On the second one, cosine theta equals negative 1 at pi. So this time I only have one solution, and it's pi.